And now we have an expert that I met him many years ago in another one program of Microsoft, in Microsoft Learn Student Ambassador Program. I would like to say that our next very special guest, I always remember him as a secret power in this community that they had in the university. And I saw him to become MVP last year, and it is a pleasure for me to see joining this program so valuable person. We are thrilled to welcome Gerasmos Alexiou, Microsoft's most valuable professional in developer technologies and experienced cloud DevOps engineer. Gerasmus is a senior DevOps engineer with extensive experience in code and infrastructure automation. He is also a Udemy instructor and an excellent infrastructure specialist with expertise in Linux, Windows, and vSphere administration. Gerasmus holds numerous certifications and associates, including Red Hat certification specialist in advanced automation, Red Hat certification engineer, Red Hat certified system administrator in Red Hat 8, VMware certified VCP data center virtualization, Microsoft certified Azure administration, Microsoft certified designing and implementing Microsoft DevOps solution. As you know, that's why I told you that he is an expert. I'm expecting Gerasme. Welcome to our AI modern cloud and AI Cloud and Modern Workplace Conference 2025. It is an honor for us to be here today. A big thank that you honor us with your presence here. George?
I would like to thank Erasmus for joining us. I met him 2 or 3 years ago in person on a Global Azure in Athens. So I had a very quick discussion with him, and I found that he's fully knowledge in DevOps. I asked him that question, and he just literally asked me the next second. So I assume that this presentation will be full of knowledge, and he will provide many insights to all of us that we are going to view it. So Gerasmos, the stage is yours.
Thank you very much for this warm welcome, and I'm really happy to be here in this conference this year. It's my first time participating, so thank you very much for organizing this and having me in this conference. So let me share my screen so that we can start discussing about my today presentation. So today we will discuss about chaos. We will test and see how we can strengthen our infrastructure with Azure Chaos Studio. A very important matter, let's say, for today's infrastructures that not many companies using. For those who doesn't know me, I'm Gerasmos Alexiou, and I have attached some links that you can find me online. So I have my blog where I share multiple articles about many technologies, and also my LinkedIn if you want to find me and connect with me. So let's start discussing about our chaos presentation today. So our agenda will be the one that is shown in this slide. So first thing first, we will explain what is chaos engineering. In order to implement chaos engineering in Azure, we can leverage the Azure Chaos Studio service. So we will see what is Azure Chaos Studio. And as I am a DevOps engineer and in general I like automating things, we will focus today in the demo on how we can automate our chaos framework. So let's say we will create anything we need for our chaos testing using infrastructure as code, and we will see how this procedure can be automated in today's environments with the best tools, let's say, some of the best tools that we have available. So, what is chaos engineering? Chaos engineering, for those who doesn't know it or haven't used it till now, is the discipline of experimenting on a system in order to build confidence in the system capability to withstand turbulent conditions in productions. So what we do with chaos engineering, we are trying to break our infrastructure, we are trying to mess things up in order to see how resilient and how robust is our infrastructure and our production environments. Netflix learned this concept firsthand when it switched from on-premise to the cloud. They experienced an outage that led to a 3-day interruption to service delivery in 2008. So you can imagine how important it is for services and companies to have their services running all the time and not experience outages as those, because of course they lose a lot of money. So Netflix, after this incident, created Chaos Monkey, which is an open source tool that creates random incidents in IT services and infrastructure, meant to identify weaknesses that can be fixed or addressed through automatic recovery process. So we can say that Netflix is a pioneer in this chaos framework, and after Netflix started this, let's say, framework, then and other companies also deep dive and created their frameworks and their tools for chaos engineering. By utilizing chaos framework, we are not 100% confident that issues will not occur, but is a very good point to start in order to make our infrastructure more robust and responsive. To have chaos engineering in our environment doesn't mean for sure that we will not have an outage someday or an incident, but is a very good start in order to build more robust services. And we can say at this point that staging environment is of course a very good target, let's say, to start experiment with chaos engineering, but the actual environment what we are serving to our clients is the production. As a result, the production environment is the best target for our chaos engineering. So let's now discuss how we can implement chaos engineering, or what some examples that chaos engineering is doing. So let's say that we have the latency injection. So DevOps teams intentionally create scenarios that emulate a slow or failing network connection. This includes introduction of network delays, slower response time, to see how our service respond to those actions. It's very important because, let's say, a slower network may bring us other issues that we have inside our application code and we haven't discovered them yet. Fault injection. This involves purposely introducing errors in the system to determine how it affects or how other dependent services work when we introduce such failures. Example of fault injections include disk failures, terminating processes, shutting down hosts, or introducing power on temperature increases. Fault injections can help organizations identify any single point of failure that we have. This is also what I'm showing in the demo. We will see that we created a web application using single point of failure. As a result, it's not something that is robust, and it will fail when we face an outage of our availability zone. We will see this later on. But as we said right now, we can inject multiple faults inside many, let's say, points of our infrastructure and see how our application and our service respond to that. Then another example is load generation. We can use load generation to set significant traffic levels beyond normal operation. This is very important also because we can see this behavior many times in production services. Let's say we have a spike event because of a specific scenario that happened. Let's say we have discounts in a big retail shop, and then we faced a big load generation. This is of course an example of chaos engineering that we can try experiment ourselves before this particular event occurs. So it can help site reliability engineer to understand bottlenecks in the system and help us as an organization build more scalable systems. And of course, we can have canary testing. This involves releasing a new product on a small future of a group of users, and we can utilize canary testing in order to perform our case engineering. Let's say we deploy a new version of our service. We use then the canary testing. We deploy it only to a small percentage of users, let's say 10% or 20%, and then we go there and perform our chaos testing in order to understand how our new version works, because many times we don't want to interrupt our real usage of our clients, and maybe we could, let's say, interrupt a small portion of our clients, of course, given that we have done anything we can in order to build robust systems. So we don't want to go and break our production because we serve clients and our organization need to perform well on that. So what about the benefit we get for utilizing Chaos Framework? First of all, we get better customer service. Customers have high expectations about the availability of the services that purchase from companies. Any downtime or inability to access what they have paid for have a serious effect on customer satisfaction and leading to lost revenue and reputational damage to our organization. So for this reason, we need testing, a lot of testing in our system in order to identify solutions that is less risk and a system will be down for a significant period of time. So we lose money. We don't want bad reputation for our company. This is why we need to build very good quality services. Furthermore, we have improved data security. Disruptions can come from bad code, server issues, or external threats. The latter can strike even with exceptional security practices. So we may have tried to build the best system ever, however, we have still issues in our system. There is not system without failures. There is no, let's say, perfect system. Every company has suffered a small or a big outage, let's say. We need to improve our security, and we can utilize Chaos Framework in order to inject failures in this area and build better systems. Also, we have minimized downtime, a benefit that we get from Chaos Framework, because Chaos engineering enables organizations to create an informed blueprint for how they can tackle issues that they occur in the future. So we perform chaos engineering, we identify some issues that we have in our infrastructure, and then we of course try to repair them and fix them. So we build a more robust infrastructure and a better system for our clients. And lastly, we have increased scalability because by utilizing chaos engineering experiment, we can identify how system allocate resources and what happens in terms of scaling in our system. So we can, let's say, benefit from a scenario that our company starts getting bigger client base and works as expected instead of having issues when we face a spike on our user base. So let's say there is an event that our company goes viral because of an offering that is advertised online, and then in a in a random moment, many clients go and register in our service. If we face downtimes or issues there, you will understand that this goes very badly for our application, because the client, even before trying our service, had issues registering, etc. So scalability is a very important factor that we must take into account when we build our services, and with chaos engineering we can discover some issues. So, as we discussed why we need chaos engineering in our organization, we will see now how we can utilize Azure Chaos Studio for this purpose. Azure provides a very good tool to build our Azure Chaos framework, and this is the Azure Chaos Studio that we discuss later on, which is a managed service that uses chaos engineering to help us measure, understand, and improve our cloud application service resilience. Chaos Studio helps us avoid negative consequences by validating that our application responds effectively to disruptions and failures. We can use Azure Chaos Studio, of course, to test our resilience against real-world incidents like outages or high CPU utilization on virtual machines and many other scenarios. So Azure Chaos Studio provides many built-in scenarios that they have already implemented in order for us to easier and test our infrastructure and easier get started with Azure Chaos Framework. So it's a very helpful tool that we can utilize for this purpose. Of course, there are other tools that you can use for your Chaos framework. As we said, Chaos Monkey from Netflix was a pioneering tool, but in this demo we will focus on Azure and Azure Chaos Studio for performing our Azure Chaos Engineering. So let's see now some Azure Chaos Studio example that we can build for our infrastructure. We can firstly use it to reproduce an incident that affected our application and better understand the failure. So let's say we had an incident, and for this incident we had identified the cause, but we hadn't fixed it yet because we need some time to fix it. Then developers write the code, try to fix the issue, and then of course we need to reproduce the issue again to see how we can fix it and if we have fixed it. So we can utilize Azure Chaos Studio to go and test this incident that occurred and see if we can fix finally the problem. We can utilize Azure Chaos Studio to prepare for a major event, a game day, let's say, as a load scaling test to validate the performance of our application and resilience. As we said, we may have a retail store that had some, let's say, viral discounts, and then we get very big client base visiting our website or our service that acts, of course, as a load test, as a DDoS attack, we would say. So this is we can utilize Chaos Studio in order to perform our performance test in our services, and it's very important to do so. We can test our business continuity and disaster recovery. We can do some exercises to ensure that our application recover quickly and preserve critical data in a disaster. So we can utilize Chaos Studio in order to test such scenarios. We can run high availability drills to test application resilience against region outages. This is the demo that we can see later on. Network configuration errors, network issues, high stress events, etc. So we have multiple examples of testing that we can perform in our application because, of course, we don't have only a single failure that can occur inside the infrastructure. We have many reasons that our infrastructure may fail, like network, infra, load, etc. We can develop application performance benchmarks, we can do load tests as we said already, and we can ensure with Azure Chaos Studio that our services migrated from on-premises work as expected in the cloud environments, because we have seen in some organization, I have also noticed that myself, that many times when we migrate services from on-premise to cloud environments, as of course they need fine-tuning, we face a lot of issues, performance things, or other let's say defects that we can face. And chaos testing is a very good candidate in order to test our service or application before going live. So we should not go live in a migration like I'm pressing the button and now I'm switching off. We as production environments and as best practices, we should first perform our load testing and then proceed with the switching to the service in the cloud. So let's start discussing a bit in depth about Azure Chaos Studio, and then we will switch to the demo. We will discuss a bit now about how it works. So Chaos Experiment is the core of Chaos Studio. The examples that we discussed in the previous here in the previous slides we could say that it's separate experiments in our Azure Chaos Studio. So Chaos Experiment describe faults that we run in our resources, in the resources that we need to run them against. So we have two types of faults in Azure Chaos Studio. We have the service direct and the agent based. The service direct are the faults that run directly against Azure resources without any installation of agents, etc. So an example of this one is rebooting an Azure Cache for Edge cluster or adding network latency to an Azure Kubernetes service pods. So let's say we have an Azure cache, our application relies a lot on this cache. We can stop it in order to see how our application works, what are the response times, and what happens. Do we face issues, etc. And also we have the agent-based failures, that this runs on VMs or virtual machine scale sets to do in-guess failures. So let's say we want to apply virtual memory pressure on our virtual machine to see how our service responds, or we may need to kill a process to see how this will respond, how our service will respond. This may happen unexpectedly sometime in our production service. A service can be stopped. Will our service continue working, or we have a single point of failure there? This is a very good candidate for Azure Chaos Studio to build an experiment for this. So, how we can produce chaos? We have the experiment, as we discussed, as the first level, and inside the experiments we have branches, steps, and branches. So when we define a chaos experiment, we define one or more steps that execute sequentially. So the steps, as we discuss here, run one after the other, as you can see from the slide. Okay, so this is an important factor. But inside the steps that we build, we have the branches, as you can see here, where we can define our faults actions. So these branches run in parallel within a step. So we can have one step that perform, let's say, 10 parallel branches, and those 10 parallel branches would be, for example, here, stop the database. Second, stop the Redis. Third one, inject some failure in our networking, etc. So we can have a single experiment that brings, as the word says, chaos in all our infrastructure, and then we can try to see how our service responds to those failures. And of course, as we said, we can have multiple steps inside a chaos experiment, and those experiments, of course, need to target something. So we have the selector, which is the resources that we want to target for this experiment that we will run. So we want, let's say, to inject CPU pressure. Where we will inject the CPU pressure? We will inject it with the help of this selector, which select specific resources based on the conditions that we have specified. We can organize the targets to run faults again in groups called selectors, as we said. And the important thing that we must mention here is that those experiments are Azure resources, as we will see later on. As we say here, the experiments are Azure resources located in a subscription and a resource group. And of course, a very helpful feature of Azure Chaos Studio is the REST API that we have, because we use it in order to create, update, start, cancel, and do many things in Azure Chaos Studio. As we will see in a bit, I am utilizing the REST API in my demo. So let's discuss a bit more about the experiment. So we have the selector, as we said, which is the target of resources that we need to target, let's say. And a selector allows us to logically group resources for use across multiple actions. So we may have a selector called, let's say, all non-prod East US VMs, which targets all non-production virtual machine in East US. Then we may need to target, let's say, West US. We may need to target only Redis cache. We may need to target only databases. So we create selectors based on what we need to target. And the logic is the description of what we do. It's the things that we discussed with branches and faults that we create in actions. So each branch has one or more actions that we will see later on, and we can also add inside this action some time delays. So we have the faults and time delays that can be created inside the branch that we create inside the experiment. So an action is an activity that is orchestrated as part of Chaos experiment. Actions are organized in steps and branches, as we discussed, and which enable actions to run either sequentially or in parallel. So every action that we do has specific properties, has the name, has the type of action, which is fault and time delays, as we discussed. And in order to perform our, let's say, chaos testing, we need to use some capabilities. Those capabilities are specific, let's say, faults that we run against a specific resource, like shutting down a virtual machine, and we must use the specific capability name in the experiment that we create. We will see this later on in the demo. So in order to understand the failures and corresponding capabilities, we can check the Chaos Studio fault library, the documentation for Microsoft, in order to see which specific capability we should use in our testing. And here, as we discussed, we have the targeting of our resources, and as you can see, we create our action, our fault, and then we target specific resources inside an Azure subscription. And as you can see, we can have manually selection from a list. We can use the checkbox in order to select the specific experiment that we want, or we can go and use a KQL query in order to target specific experiment and make our logic more advanced. So I have added a link, of course, for the Azure Chaos Studio documentation, and also I have added you the demo link in GitHub, which we will discuss right now. After the presentation, I will go also and upload the presentation slides in this GitHub URL. So we will go now and deep dive in the demo, because this is the important thing to see here in order to understand things better. So let's start by navigating in Azure portal first. But let me ask Yorgos or Konstantinos, I'm okay, right? With the sound continuing, right? All visible?
Yes, yes, of course.
Perfect. Okay, so we navigated now inside Azure portal, and in order to find the Chaos Studio, we must search in the search Chaos Studio. So we go inside our Chaos Studio, and inside it we can see the targets that we discussed, which is the specific resources that we want to target, and the experiments. A very important thing here to discuss is that in order to run an experiment against a resource, we must first enable it. As you can see now here, we have a web app, a Chaos web app, which is located in this specific resource group. And this, as you can see, is enabled, which means that is an enabled target for Azure Chaos testing. This is, of course, a safety mechanism from Azure Chaos Studio in order not to break our infrastructure by mistake. In order to start utilizing a resource for chaos testing, we must first enable it. This is a very important factor, as you can see. And because I will do this action with infrastructure as code and Terraform, we will go now and disable this target by hand in order to see how this is performed also through code, and we don't have to do it manually. So I have pressed the disable target here, and here we can go and see what experiments we have created. So as we discussed, the experiments are located inside the experiments tab. And inside the experiment tab, we have the start button, edit, delete, etc. So if we go in edit, we will see that we have the branches that we discussed and the steps. So this is a step. We can add other steps and decide the experiment. We can have multiple actions inside our branches. So this step, the first one, is called example. I can add other steps as well, as you can see here, steps 2, step 3, etc. Inside the step, I have the branches, and inside the branches, I have actions. So this action that I have created, as you can see, is a stop app service action. If I press inside the add action, you can see the two different type of actions that we have. It is default and delay. The delay, as the name indicates, is a delay that we can add for a specific amount of time in order to let's say inject timeout and see how our infrastructure responds after our failure. So we have the time delays and the faults, and let's now go and see the faults that we discussed. As you can see, we have many type of faults that as Azure already provides for us in order to target our services, and those faults, as we said, include a specific capability, and this capability we will see how it's translated in the code. We will see the specific keyword that is needed for this capability to work. And of course, when we select the fault that we need to use, we need to specify the target. As you can see, I have selected a specific fault type, and I don't have such resources on Azure. That's why I cannot see it in the target selection. But in order to see that in target selection, we should have first created as a target here in Azure Chaos Studio. Right now, I don't have anything enabled, so I cannot find a single resource in order to target in my experiments. So, as we discussed right now, how experiments work and how we can utilize our experiments, we will go inside Azure and press the delete resource group here because I will create all those things automatically. A very important thing to mention here is that this Azure Chaos experiment, as you can see, I have created a managed identity, and I think this one is user assigned. So this managed identity is an important factor that you need to create also, because the experiment that runs performs some actions inside Azure. My example that we see in a bit stops a specific web app that we have created. So in order to stop this web app, of course, I must have the specific permissions in order to do so. So when I create my experiment, you will see that the identity is needed also inside the experiment in order to specify what here in the settings, in order to specify what actions this experiment can execute. So in my case, I think I have specified contributor in a subscription, or I don't remember the permission that I have provided, but in your case, yes, I have provided contributor in my subscription, but in your case, of course, you can deep down and provide the necessary permissions that are required based on least privilege. This is the best practice to do. So in your case, you will not add contributor, let's say, but you can add only the API for stopping web apps or whatever you have created based on your experiment. So let's go now and see what we have created for this demo. Right now, as you can see, we have a web app. This web app is an Azure web app which is located in this Azure resource group, and it's just a web app that runs on an app service. What is the issue here in our web application? Imagine this is an API that we serve in our clients. What is the issue here? This is not multi-AZ, this is not an advanced let's say setup. It's just a single web app that we have created, and it's not created, of course, based on best practices and based on high availability multi-region web app architecture. So we haven't created something like this. We have created just a web app that's serving our clients, which is a very bad thing to do in production environment. And this is the reason why we could issue failures unexpectedly in our infrastructure, because sometimes we may lose this specific region, the specific AZ that we have deployed our app service. So what happens? Or our deployment breaks, or something else happens in our application. What happens in this case? This is the scenario that we will simulate now using Azure Chaos Studio. We will go and stop our app service using Azure Chaos Studio, and of course, as we don't have best practices architecture, we will see that our application will fail and we will not serve our clients using our web app. And how we will do that? We will do by creating the experiment that we discussed previously. So we will do that through infrastructure as code, Terraform, and Azure REST APIs, and we will see, and Azure DevOps, of course, and we will see right now how we do that. As I said in the beginning, this is the link for my demo, but also you can find the blog post in order to see all the steps, but we will explain right now how this happens. So as I have already, I will go and delete my resource group. So let me refresh. I will delete the resource group in order to create those through Terraform and infrastructure as code. So we will wait a bit for the resource group to be deleted. But in the meantime, let's go and discuss a bit how we can implement this through infrastructure as code. So I have created my example using Terraform. In order to use Azure Chaos Studio and Terraform, you use the Azure RM provider, and inside the Azure RM provider you have the the specific resources, the specific properties that you need in order to create your experiments. So we will see that in the code that I will show in a bit. And of course, I have used also the REST API in order to interact with Azure Chaos Studio. And why I have done that? Because I want to make end-to-end the flow automatic. And how I do that? I do it using Azure DevOps. And we will see now how this is performed. Let me switch to Azure DevOps. So we have built a pipeline in Azure DevOps which contains two stages. So as you can see here, I have built an Azure pipeline which contains one stage and the second stage. This stage goes and create all our infrastructure using Terraform. So we go in the first stage, we create the specific experiments that we need to run, and then using the second stage, we go and trigger this experiment through code, and we run the experiments that we need to do. So we make end-to-end the procedure automatically. We don't press a single button in order to perform our chaos testing. And of course, in production environments, this is how we need to perform our chaos engineering in order to know exactly what we are executing, against which resources, etc. So we have everything as a code in order not to make mistakes, let's say. So let's now navigate a bit in the pipeline that we have created. The code for the pipeline is located in GitHub. This is why you see the authorizing, is the repo that you see here. So we can see also the pipeline code from here. This is the pipeline that I have created. And inside the pipeline, I have some variables in order to target a specific resource. So the resource that I want to target is the Chaos web app, which is located in Chaos resource group. As you can see, I have some jobs inside my pipeline. This job it needs Terraform, installs Terraform, it needs etc. So the important step here is that I'm performing a Terraform apply. As you can see, I'm performing a Terraform apply and I'm passing a variable file in the Terraform apply. So in order to do so, of course, I have created a service connection with my Azure subscription. This is the Azure subscription. I will create my resources because all those resources are created through my pipeline. And my next stage is the chaos run, as we discussed, which is performed through the AZ CLI and the REST API of Azure that is provided. And as you can see, I'm targeting here some resource group and experiments through variables. So when we run this pipeline, here you can see the service connection that we discussed, and I have already my Azure subscription set up here. So when we are going and running this pipeline, you can see that the infrastructure is built using Terraform, and right now we will go and see the Terraform code in order better to understand the things that we do. So inside my Terraform code again, I have some variables here. It is where I'm targeting the web app and where my resources will be created. So my resources created are under Chaos Terraform, and as you can see, is different than the resource that I'm actually targeting. Very different resource group. We can have them also in different subscriptions also. So what I do here in my Terraform code, of course, I'm using the Azure RM provider, and I'm using some resources and some data. My data resource is the Azure Web App that we already have inside our infrastructure, and I'm getting this data resource in order to using in the target that I will create later on. So as you can see, I'm creating the target, the thing that we said that we must register our target before using it. So I'm using the Azure Chaos Studio target Terraform property in order to create my target, and this target would be this web app. This web app is brought through a data resource, and of course we have a resource, a new resource, which is a resource group, and this resource group is where our infrastructure components will be created. What are the infrastructure components that need to be created? Is the managed identity, the user assigned that we discussed, and also the experiment, because those are also resources in Azure. So we create those inside another resource group, which is the Chaos Terraform resource group, and the important thing is the experiment itself that we create. So the experiment is created, of course, based on variables, etc. We have the selector, which gets the target ID from the resource that we have created here, from the Chaos Studio target, and it have the specific selectors and the type of action that we perform. As you can see here, the type is continuous, no time delay, and we run it for 10 minutes. The important thing that we must see here is that we also need the Azure Chaos Studio capability. As you can see, inside the action, we need to use the URN property, which is the Azure Chaos Studio capability that we have created. And what is this capability? Is the actions that we described have specific capabilities. Those capabilities are based on resources. So we must go and use a specific keyword that Microsoft provides through the documentation for this specific resource. So for the web app that I'm using, the capability is called stop-1. So you can find those through the documentation. I have links for those also in my blog post. So you must write here the specific capability that is required in order to perform your experiment. So if you have this wrongly, like this one, or stop or stopped, something like that, if you misspell or don't write it correctly, this will not work, and your code will not be executed successfully. So let's go now and run our pipeline end to end to see what happens. Let me find the experiment, is this one, the pipeline. So when I have deleted all my resources and I don't have something, because Terraform will face an issue if I have already created my resources, I will go now and run my pipeline. So we will run the pipeline to see how things go and how all the flow is automated without having from us to perform a single click. As we discussed, the first step is the Terraform creation, and the second step is the actual run of our experiment. So the code started running. We will see that we have the Terraform initialization install. We will see that we will have the Terraform apply here, that we will start reading our data resources, and also it will start creating our Terraform resources. When the Terraform is running, you will see that a new resource group will be created, which will be called Terraform Chaos Terraform. But also inside the Azure Chaos Studio, you will see that a new target will be registered. As we said, the Chaos target will be registered automatically through code and not by clicking. So in a bit, when the pipeline runs, we will see that so it started applying, we will see that the target will be created inside Azure Chaos Studio. So not only we have the options to perform chaos testing, but we can automate everything end to end and perform those through code, which is very important. As you can see by refreshing, we have our capability enabled, so we don't have to do something by hand. And as you can see here, we have our experiment also created, which is the experiment that we discussed will go and stop our web app. As you can see, the pipeline is still running. Okay, we got right now in the second step, which is the one that will go and run the experiment through the REST API. So right now it finished, our pipeline finished. So by navigating in Azure, we will go and make a refresh. And when we make a refresh, you can see that our chaos experiment started. We have a pre-processing, and after some moments, you will see, we will wait a bit, and after some moments, we will see that our experiment, the logic that we defined inside our experiment, will be executed if we don't have issues or failures in our code, in the configuration that we have provided. We will see that the experiment will run and will break our infrastructure as we specified. So you saw the status went from waiting to run to running. So inside the experiment, we have also details about the start time, end time, and of course we have details about what experiment did and if we had issues, etc. So you can see a detailed output from Azure about the experiment that we have created and the procedure that we needed to implement, which is a very good feature in order to know what we are actually doing. And as you can see, the expected output of our application would be to have an issue because our web app stopped. So what we understand finally from this demo and from this exercise, that we don't have a best practice multi-AZ application, but we have a single point of failure in this web app and service that we need to fix, of course, to serve our clients better and have the best infrastructure possible that we can have. So the experiment will end in a bit. And by utilizing such practices, of course, we can build our Azure Chaos Studio in order to break our infrastructure for a good reason, of course. So that was the presentation. I hope you don't get bored and it wasn't much. I hope you enjoyed the demo. I don't know if someone has questions or...
It was an amazing presentation and very interesting presentation.
Thank you, Konstantine.
It is, for me, it is